So hello everyone, welcome to the channel. So in this video, we're going to focus on rainfall intensity and wet day analysis using NOAA PERSIANN-CDR data in Google Earth Engine. So now let's get started. So the rainfall patterns are critical component of hydrological cycle and significantly influence the water availability, agricultural productivity, and the broader ecological balance. Understanding the rainfall intensity and the distribution of wet days over time provides a valuable insight for the hydrological modeling and disaster management and climate change assessment. So in this context, satellite-derived precipitation dataset have emerged as an indispensable tool for the rainfall analysis, offering an extensive spatial and temporal coverage. So the NOAA dataset is a reliable and widely used source for a high resolution precipitation data at global level. So developed through an advanced machine learning algorithm, it integrates the multiple satellite and ground-based observation, making it suitable for evaluating rainfall characteristics across diverse geographic regions. So we're going to focus on analyzing the rainfall intensity and wet days distribution over a large spatial domain. So analysis conducted during the NOAA or using the NOAA dataset using Earth Engine covers a period from 2023 to 2024 with the additional investigations for a selected historical years of 2010 and 15. Specifically, the study aims to quantify the total number of wet days defined as the dates with the precipitation equals or exceeding 1 millimeter. Compute the total precipitation for a specified period. Derives the rainfall intensity calculated as a ratio of total precipitation to the number of wet days, and compare the interannual variation in rainfall intensity by calculating the metrics for 2010 and 2015. So let me get back to Earth Engine. So now to begin our analysis, specifically first we have to select our region of interest. So to select a region of interest, we're going to navigate to this option called draw a rectangle. So you can select this particular tool and you can draw a study area of your choice. So like I have created my study area, for example. So selected entire Asia, so you can able to see that. So in this way you can able to select your study region, and we're going to navigate this option called show the generated codes here, and in that we're going to select a latitude and longitude of a study region, and we're going to copy it and paste it here in our region of in the variable called region coordinates. So once you paste it here, we are ready to we have created our region of interest. So let me turn this off here for visualization. So to define a region of interest, we define this variable region coordinates, and we're going to mention the latitude and longitude of a study region. And to create as a polygon, we define variable region polygon equals to Earth Engine dot geometry dot polygon region coordinates. So this particular variable contains the latitude and longitude of our study region. So next we're going to load our NOAA PERSIANN-CDR dataset and filter for the year 2023 and 2024. So let me explain about this particular dataset here. The PERSIANN-CDR precipitation estimation from remotely sensed information using artificial neural networks and climate data records. So this particular data is the daily global precipitation product that spans the period from 1983 to 2024. So the dataset provider is NOAA NCDC. So using this specific code, you can access this precipitation dataset. So these are the following bands that is available. We have only one band that is available in this dataset, that is precipitation, and the units for this particular is millimeter, and the minimum and maximum values are given here. The description, it gives us estimated daily precipitation. And the resolution of this particular dataset is around 27,830 meters. So this is the resolution of this particular dataset. So now let me get back to Earth Engine. So to access this particular dataset, we define this variable called precipitation data equals to EE, that is Earth Engine dot image collection NOAA PERSIANN-CDR. So using the specific code, you can able to access the NOAA dataset. And now we're gonna filter based on this specific timeline, that is we're going to filter between 2023 to 2024. So to do that, we define this dot filter date 2023 2024. So using this particular function, we can able to filter between this particular years. So next to calculate the total number of wet days with the precipitation greater than or equal to 1 millimeter. So that is the precipitation that is greater than 1 millimeter. So to do that, so to calculate the total number of wet days, we're going to define this variable called wet days equals to precipitation data referring to this particular dataset, that is our NOAA dataset, dot map function. We're going to create a loop function here and we're going to return the image which greater than 1. So to create a binary mask for the wet days, we defined as return image dot greater than 1. So this particular formula we have referred to this website called the Climdex. We're going to navigate this option called Climdex here. And now here we're going to visualize this the website's interface here. So here we're going to navigate this option here, the drought indices. I'm going to click this and we're going to navigate to so we're going to navigate this particular formula called the simple precipitation index. So here let RR be the daily precipitation amount on the wet days. Here the double R is greater than or equals to 1 millimeter in period, and if the W represents the number of wet days in J. So this is the formula, that is STI equals to summation W. So RR, which represents the daily precipitation amount on wet days, and the W, which represents the number of wet days. So using this particular formula, we can calculate the simple precipitation index. So let me get back to Earth Engine. So the wet days here represents the number of days, the number of wet days in which the daily precipitation, where the precipitation is greater than 1 millimeter. So we're gonna basically detect all pixels or separate all pixels in different dates in there. The precipitation was greater than 1 millimeter. So basically we need a loop function to pass all the existing images. So that's why we created a loop function here. So now the function returning the input image greater than 1, which represents the precipitation greater than 1 millimeter, which creates the binary mask for the wet days. So here we are making a binary image in which the pixel with more than 1, the 1 millimeter precipitation returned as 1, and the rest of the pixel returned as a 0. And at last we defined as a sum function to sum all the binary masks to get the total wet days for each pixels separately. And now to add this layer in Earth Engine, we define map.add layer and wet days referring to this particular variable, and with the default visualization parameter, and output the name as a wet days count. So basically we're going to visualize the global wet days here. So this is the global dataset, so we can visualize the global wet days. So now to visualize the wet days, we're going to navigate to the layer section. First we have to run this code. I'm going to click this option called run script. So once you did that, we're going to navigate this layer called layers section here, and we're going to click this option called wet days count as specified here as a wet days count. So we're going to click this layer called wet days count here. So to visualize the global wet days here. So here you can able to visualize the wet days here. You can see that the wet days in grayscale image. So we're going to navigate to the layers section and click this option here. So in that, and here we're going to navigate this option called customs, and in that we're going to click this option called stretch 90%. So once you apply it, we have this ranges starting from 25 to 315.9. So basically it shows us the frequency of the wet days for the different cells. So I'm going to click this option called apply. So it's loading here. And also you can use a different stretch type here. For example, you can also select the stretch type of 98% stretch type. So now the value ranges from 7 to 343 here. You can able to visualize it. So we have this value starting from 7 to 343.9 here. So only few number of pixels might be noisy in our image. So I'm going to click apply here. So it's going to load again the image. So now I'm going to close this. So you can able to visualize the image now here. So here the brighter pixel which shows the higher frequency, and the darker portions which indicates the lower frequency of wet days. So for example, globally, you can able to see that the brighter pixels, which represents a higher frequency of wet days. So you can able to see that in this image here. And similarly, the darker portion, which indicates the lower frequency of wet days. So for example, consider in Africa, so you can able to visualize in the central part of Africa, we have a higher frequency of wet days compared towards the southern and the northern part of Africa, which has a lower wet days. Let me turn this off here so you can able to see now. So central part of Africa has a higher frequency of wet days compared to the southern and northern part. And northern part, which indicates the comparatively a lower frequency of wet days, which indicated in the darker color here. So for example, if you want to visualize the wet days more clearly, we're going to navigate the layer section here. So in the wet day count layers, I'm going to adjust my opacity of my this particular layer. So you can able to see. So the whiter portion, which indicates the higher frequency of wet days. So we can able to see here in Africa, these are the following study region which falls under a higher frequency of wet days. Comparatively, in India, you can able to see in towards the southern part of this areas has a higher frequency of wet days, and also towards the northern part we have this in the Himalayan towards this range here. So we have a higher frequency of wet days. So which is clearly highlighted in this the white gray tone here, the brighter tone. And similarly towards the east, you can able to visualize the Malaysia, Indonesia, and Philippines has a higher frequency of wet days. You can able to see even the Vietnam has a higher frequency of wet days. So based on the brighter pixel values, you can able to see which indicates the higher frequency of wet days. And similarly in Madagascar, you can able to see here. And we have specified this the wet days based on the criteria, the precipitation data which is greater than 1, which indicates the wet days. So based on the precipitation condition, that is when the precipitation that is greater than 1, which indicates the wet days. For example, using our inspector tool here. So for example, I'm going to click on this particular country called Malaysia. So you're going to visualize this particular precipitation. So total precipitation, you can able to see here the wet days count, so which is around 304. So we are basically visualizing the number of wet days for each pixel. So this particular country which falls in the equatorial line here, so which indicates 304 days of 304 days have a precipitation more than of 1 millimeter. And similarly, we're gonna navigate to here in Ethiopia. I'm gonna click this, and the wet days count here, which indicates 213 days of wet days receiving the precipitation more than 1 millimeter. And similarly towards the in India, so in the northern part, we're gonna click this. So we're gonna click on this Himachal Pradesh here and visualize the wet days count. So the total wet days count is around 180 days, having received the precipitation greater than 1 millimeter. So based on the formula here, so now we have calculated the W. So the W, which indicates the number of wet days. So now we have managed to calculate the number of wet days. So next we're going to focus on the daily precipitation amount on the wet days. So we want to calculate the sum of the precipitation, that is RR. So there is our second variable. So let me get back to Earth Engine. So to calculate the total precipitation for a given period. So the second variable is to calculate the total precipitation for the given period. So as mentioned here, so we're going to calculate the RR, that is daily precipitation, the amount of wet days. So let me get back to Earth Engine here. So to calculate, we define this variable called total precipitation equals to precipitation data dot map function. So we're going to create a loop function here. So in the next step, we have to make a threshold. For that, we define this variable called mask equals to image dot greater than equals to 1. So it's going to mask for the precipitation or greater than or equals to 1 millimeter. So basically, we are applying this particular condition in order to separate the number of wet days pixel from the dry pixels. from the each input image greater than or equals to 1. So it's going to select the pixels as a wet for more than 1 millimeter precipitation. And in the next step, we must return each image that is only included and update mask. So the update mask that is only included the regions with the precipitation that is greater than 1 millimeter. So here the pixels in which the precipitation is not greater than 1 millimeter will be removed. And last, we're gonna define this function called dot sum function to sum all the binary masks to get the total precipitation for the given period. So for that, we're applying this function dot sum function. So finally, we're gonna get a sum of total precipitation for the wet pixels. So in this way, the total precipitation for the dry pixels were not considered it for the calculation. So now to visualize the result, we defined the map.add layer, the total precipitation, which represents this particular variable here, and with the default visualization parameter, and we're gonna output as the total precipitation here. So let us run this code. We're gonna navigate to this option called run script, and we're gonna click run script. So we're gonna navigate to the layer section here, and we're gonna click this particular layer called the total precipitation. As I defined here, you can able to see that the total precipitation. So we're gonna click this layer and we're gonna turn this on. So now here we have some of the precipitation values, some of the total precipitation value here. So we're gonna navigate this option. I'm gonna click this option here. So this is the total precipitation for wet pixels only. So for visualization, we're gonna navigate the custom option here, and in that we're gonna click this option called stretch 90%. So now the value ranges from 499.39 to 4486.4 millimeter. So it ranges from here. So from 499 to 4486. So we're gonna click apply. So this is the total precipitation pixels that is experienced during a year. And for example, we have this some noises here. So you can able to see some pixels which has a noise here. So this specific noise might be observed for this particular year. So for this year 2023. So our timeline starts from 2023 to 2024. So we can check for other years we can this particular noise might be avoided in those images. So now we're gonna close this. So we're gonna navigate to the layer section here, and gonna reduce the opacity of this layer. So now you can able to see here. So to view the total precipitation, so we're gonna click on the study region here. So let me click here in Uttarakhand. So you can able to see here the total number of the wet days is around 228, and the total precipitation is around 1175.79 millimeters. So now we can calculate the rainfall intensity. So we have these two variables, that is the number of wet days and the total precipitation. So now to calculate the rainfall intensity, the total precipitation is divided by the number of wet days. So to do that, we define this variable called the rainfall intensity equals to the total precipitation dot divide wet days, and we're gonna rename as rainfall intensity. And to add this layer and to add a visualization for this particular layer, we defined map.add layer, the rainfall intensity, and we're gonna mention the color palettes for this particular layer. So we're gonna mention with the starting with the red, white, and blue to indicate the different rainfall intensity, and output the layer name as the rainfall intensity, and with a specific zoom level. So we're going to run this code. We're going to navigate to this particular option called run script and click run. And in the layer section, we're going to navigate to this option called rainfall intensity. And I have turned this layer on called rainfall intensity. So now the layer has loaded here. So we're going to navigate this rainfall intensity layer, and I'm going to click this option. So now in the custom section here, I'm going to select the stretch 90%. So now the value ranges from 3.19 to 20.7, and I'm going to click apply. And let me close this. So the layers are getting loaded here. And you can also set the opacity as your choice here. You can adjust this opacity. So here the red color which represents the lower rainfall intensity, and the blue color which represents the higher rainfall intensity. So you can able to observe here all the blue portion which indicates the higher rainfall intensity, and all the red region which indicates the lower rainfall intensity. So for example, in India, you can able to visualize here in the eastern and the western part, we have a higher rainfall intensity, which is clearly indicated in this image here. So now here you can able to visualize it more clearly. So let me zoom out here, so we can able to see the globally. So which is the country which facing a higher rainfall intensity. So you can able to see here all the blue portion which indicates the higher rainfall intensity, and the red which indicates the lower rainfall intensity, and the white portion which indicates the moderate level of rainfall intensity. So you can adjust the opacity either here in this layer section here, or you can able to adjust the opacity in the code itself. So for example, I have mentioned the opacity to be around 0.5. So you can able to visualize the blue indicates the higher rainfall intensity, and the red which indicates the lower rainfall intensity. Now to export this particular image to a Google Drive, we defined as a export.image.drive, and image we are defined as the rainfall intensity representing this particular variable, and description. So rainfall intensity for 2023 to 2024, and the spatial resolution of this particular image is around 27,000. And the coordinate reference system is EPSG, and the region is our. So you can select your study area boundary. So as specified in the start of this video here, we have mentioned our study region polygon, and you can export that particular image and choose your folder as a rainfall analysis. So now in the task section, we have this task called unsubmitted task called the rainfall intensity 2023 and 2024. So to export this rainfall intensity map to your Google Drive, so we're going to click this option called run, and window pop-up saying initiate image export. So the task name is for rainfall intensity for 2023 to 2024, and we have specified the coordinate reference system and the scale of around the spatial resolution of around 27,000. And you can export your drive to your Google Drive or to your cloud storage or to your Earth Engine asset. So now we're going to export to a drive. So once you did that, we're going to click this option called run to export this image to your Google Drive. So now in the submitted task, you can able to see there is a the currently exporting this rainfall intensity for 2023 to 2024. So it's going to take some time here because our study region is pretty large. You can able to see here. So we have taken the study region. So this is our study region. So next, in our next step, we're going to focus on define a function to calculate the yearly rainfall intensity. So now in the submitted task, you can able to visualize the rainfall intensity map has been exported to our Google Drive. So it took less than 2 minutes to export this rainfall intensity map to our Google Drive. So next we're going to focus on define a function to calculate the yearly rainfall intensity. So we're going to define a function to calculate a yearly rainfall. So we're going to specifically mention a year, and we're going to calculate the rainfall intensity for for the advancing years. So for that, we're going to define this function called calculate rainfall intensity. And in this function, the first input, that is the first argument, is our input image collection. So we have mentioned as a collection which represents our image collection. So in the next argument, we have mentioned as the date or the year you could like to calculate. So the other important parameter, that is argument, is our threshold, because the threshold is these are our dynamic arguments that can be changed from one to another study here. So basically we have applied a threshold value previously is around greater than 1 millimeter, greater than or equals to 1 millimeter. And you can also change the threshold value according to your wish. So you can increase the threshold values according to your choice. So next, we're going to define the start date. So for that, we defined this variable called start date equals to earth engine dot date, and we're going to specify the year, and plus we're going to mention the default month and day. So next, we're going to define another variable called filtered collection. So we're going to filter with a specific date. So for that, we define this variable called filtered collection equals to collection dot, referring to our image collection. That is our NOAA PERSIANN-CDR dataset, and we're going to filter with a specific date, the dot filter date. So the start date, which indicates this particular variable. So basically the filter date function has two variable. First is the start date. So the start date will be the year, and for the end date, we're going to mention as, for example, I'm going to calculate it for, so basically the start date dot advance 1 comma year. So the start date, it advances the start date by 1 calendar year using this dot advance function method. So for example, if the start date is 2010 January 1, and it advances will be the start date dot advance 1 year will calculate the 2011 January 1. So once you filtered your target, the target year, so next we're gonna focus on next we're gonna calculate the yearly wet days. So to calculate the yearly wet days, we're gonna define this variable called yearly wet days equals to the filtered collection dot map function image. We're gonna return the image dot greater than or equals to the threshold value we have mentioned previously, that is 1 millimeter. And last, to get the sum of yearly wet days, we're gonna define this function called dot sum function. And similarly, to calculate the total yearly precipitation, we're going to define this variable called yearly total precipitation equals to the filtered collection dot map function. We're going to create a loop, and we're going to return the image dot update mask, and image dot greater than or equals to threshold. So basically the masks, it masks the value in the image that are less than the specified threshold. So the specified threshold is around greater than or equals to 1 millimeter. So for example, the image dot greater than or equals to threshold compares each pixel value in the image to the threshold value, which is around 1 millimeter, and it's going to return the binary mask. For example, if the true where the pixels values are greater than or equals to the threshold, and 0 is a false otherwise. And the image dot update mask function, it applies the mask to the image where the pixel where the mask is 0 is excluded. So only the value that are greater than or equals to 1 millimeter will be included. And last, to calculate the total precipitation, yearly total precipitation, we define this function called dot sum function. So now to calculate the rainfall intensity. So now to calculate the rainfall intensity, we defined another variable called yearly rainfall intensity equals to the similar formula we have applied previously, the yearly total precipitation, and we're going to divide it by the yearly wet days. And we're going to rename by as a rainfall intensity, and we mentioned as a plus here, So we have mentioned the rainfall intensity plus year. So we created a string that includes year. For example, rainfall intensity 2023. So it is useful, ensures that output image has a distinct name, and useful for organizing and interpreting results when analyzing multiple years. So for that, we have mentioned as a plus here. So in case you're focusing on the rainfall intensity for 2023, so the date will be automatically specified in the image as 2023 rainfall intensity. So next, to add the rainfall intensity layer to the map, we define this as a map.add function, and we define this variable called yearly rainfall intensity, referring to this particular variable as specified previously to calculate the rainfall intensity. And we're going to add a specific color palette to this layer. For example, the color palette's going to add as a red, white and blue, which indicates red which indicates the lower rainfall intensity, and the white which indicates the moderate rainfall intensity, and the blue which indicates the high rainfall intensity. And we can output the layer name layer as a rainfall intensity plus the year, and we have specified the opacity to be around 0.5. And last, we're going to calculate the rainfall intensity for any specific year. So for example, if you would like to calculate rainfall intensity for 2010 and 2015, so for that we're going to specify the intensity 2010 equals to the calculated rainfall intensity, and referring to the image collection of NOAA PERSIANN-CDR, and we're going to specify the date, that is year. So we have previously mentioned here, for example, and we're going to specify the year and also the threshold value. So we have specified the threshold value to be around 1 millimeter. And similarly, if you want to calculate the intensity, the rainfall intensity for 2015, so we're going to apply the similar code here. So we're going to mention this 2015, and we're going to apply mention this calculated rainfall intensity, referring to the image collection NOAA PERSIANN-CDR, and we're going to specify the year and the threshold value. Similarly, you can do a number of analysis here by specifying the year of your choice and the threshold value. And last, to export this to rainfall intensity map to your Google Drive, we're going to define as an export yearly rainfall intensity. We're going to define as export.image to Drive, and image we're going to refer it as a yearly rainfall intensity. Description, rainfall intensity plus year. So automatically the year will be specified here. In the export image, automatically the year will be specified, and the spatial resolution is around 27,000, and the coordinate reference system is EPSG 4326, and the region polygon, that is our study area polygon we have mentioned earlier. So this is our region of interest, and folder is our rainfall analysis. So we're going to return the yearly rainfall intensity. So now we're going to run this code. We're going to navigate to this option called run script and click run script. So now in the task section, we have this two tasks called rainfall intensity of 2010 and rainfall intensity of 2015. So we can export this image by clicking this option called run, and a window pop-up saying initiate export. So we can start export by clicking this option called run, as I mentioned previously. So now let us navigate to the layer section and visualize the result. So we're going to navigate to the layer section and click rainfall intensity of 2010. So now we're going to navigate to the layer section here, and going to click this option, and going to set this custom option to stretch 90%. So now the value is going to change from 2.7 to 17.04, and we're going to click apply. So now we're going to visualize the rainfall intensity for 2010. We're going to close this. So you can adjust the opacity according to your choice here. So can I adjust my opacity? So I have mentioned previously the blue which indicates the high rainfall intensity, and the red which indicates the low rainfall intensity, and the white which indicates the moderate level of intensity. So you can able to visualize the high rainfall intensity. So it is along the equatorial line. So the countries which is falling in this equatorial line which faces a high rainfall intensity. So based on this image, you can able to visualize it. The very high rainfall intensity is indicated here. So all the blue regions. And similarly, we're going to navigate to the layers section, and we're going to visualize the rainfall intensity for 2015. I'm going to turn this off. and I'm going to navigate to the layer. I'm going to click this option, and in the custom section I'm going to select as stretch 90%, and once did that, the range value appears here. It ranges from 2.9 to 17.72 of rainfall intensity. So I'm going to click apply, and we're going to visualize the result for the rainfall intensity in 2015. So you can adjust your opacity. So now we can able to visualize rainfall intensity in 2015, and this is a scenario in 2010. And let me load this image. I got an image to match the opacity. Yes, this is the scenario of rainfall intensity in 2015, and this is the rainfall intensity in 2010. So you can able to visualize the change of rainfall intensity. So this is rainfall intensity in 2010, and this is the rainfall intensity in 2015. So in this video I have shown you the rainfall intensity and wet day analysis using NOAA PERSIANN-CDR data in Google Earth Engine. So the code link is available in the description. So thanks for watching, and make sure that you subscribe to our channel and give us a like.